In this problem, we're in a boat on one side of a riverbank. The river is flowing southwards at 2 meters per second. And in our little motorboat, we're able to travel at 4 meters per second relative to the water. And our goal here is to go from our starting point over here, and we want to end up traveling directly across the river to here. That's what we're trying to accomplish. Now let's think about this for a moment. If we were to simply aim our boat and point it directly eastward in the direction that we actually want to go, what's going to happen is that if we just pointed the boat this way, because there's a southward current, the boat wouldn't actually end up moving this way. It would end up drifting southwards as it moved, so it would end up going kind of like this. But we don't want it to move like that. We actually want it to move like this. So what we can do is we'll need to point our boat and aim it sort of upstream like that, so that because it's aimed upstream, that will kind of counterbalance. We want to counterbalance the southward drift of the motion so that it ends up going like this. That's our goal. Okay? So, how can we think about that? Well, let's just draw out a figure here. We want to aim our boat. Our boat is capable of traveling at 4 meters per second relative to the water. And we want to aim it somewhat upstream at 4 meters per second, such that the upstream motion compensates for the current, the southward flowing current, which is flowing at 2 meters a second, so that the net result is that we end up traveling this way. So what I've drawn here is actually the solution to our problem. The idea is we're going to aim our boat so that it has a velocity relative to the water, 4 meters per second at some angle here, slightly upstream, so that the 2 meter per second current this way gets compensated for, and so that the net result, our net velocity relative to the ground, the velocity of the boat relative to the ground, will be purely horizontal like that. So now we're in business. Notice that we have a nice little triangle here, and so when I add the 4 meter per second vector with the 2 meter per second vector, I get the blue vector. That's the velocity relative to the ground, and the magnitude of that vector, I can use the Pythagorean theorem. The magnitude of this vector is going to be 4 meters per second squared minus 2 meters per second squared, which is equal to 16 minus 4, 12, so the square root of 12 meters per second. So in other words, let me just redraw that blue arrow. So the boat is going to end up going square root of 12 meters per second horizontally across the river. Simple as that. Now we're also asked, what angle do we have to aim the boat at? What is this angle theta such that it actually moves horizontally? And again, if we look at this triangle right here, we can just use a little bit of trig to figure that out. Namely, we notice that the sine of that angle is equal to 2 meters per second over the hypotenuse, 4 meters per second. I'm just using opposite over adjacent for the sine, and that's equal to 1/2. So therefore the angle is equal to the inverse sine of 1/2, which turns out to be 30 degrees. So if we aim our boat at a 30-degree angle upstream, then as the current causes it to travel southwards, the net result is that we'll end up going straight across.